we'll see problems based on Butterworth filter. So first type of problem will be like this. A Butterworth low pass filter has to meet this following specifications. Kp is this much, omega p is given, Ks and omega is given. HAS of nth order Butterworth filter. Determine they have given HAS. See, actually they have given normalized low pass filter values. We have to find analog low pass filter from it. Okay, so how do we do that is what we require. Actually this Kp, omega p and all, they will give it as passband attenuation, passband frequency, stop band attenuation and stop band frequency. Don't get confused if they give such terms in question. This passband attenuation or passband gain is nothing but your Kp. Passband frequency is omega p. Passband stop band attenuation or gain is Ks and stop band frequency is omega s. So let us see what to do first. Whenever you have to design a Butterworth filter, you need three things. Those three things are order, transfer function, and cutoff frequency. This is omega c, this is cutoff frequency, this is transfer function, and this is n order. Whenever we start designing Butterworth filter, we take normalized low pass filter. For this normalized low pass filter, omega c will always be equal to 1 radian per second. Okay, so in this question they have given us Kp is minus 1 dB. So write the given data first. So Kp is 1 radian per Kp is minus 1 dB. Omega p is 4 radian per second. Ks is minus 20 dB and omega s is 8 radian per second. So this is the data given to us. Now what should we do from this question is, first as I said, you find the order. To find order, the formula is n is equal to log of 10 power minus Kp by 10 minus 1 whole divided by 10 power minus Ks by 10 minus 1 whole divided by 2 log omega p by omega s. So this is the formula that we have for finding n. So first you write n is equal to log of, what is the Kp value that we have? That is 1 minus 1. So when you substitute minus of minus, it becomes plus 1 by 10 minus 1 by 10 power. Ks is minus 20, so I write it as plus 20 by 10 minus 1 whole divided by 2 log 4 by 8. All these things are given in question, so life is easy. By this we will find n that comes up to be 4.328, which is approximately equal to 5. So like this you found out the n value. After finding the n value, what should you do is, for the normal calculation that we have, when n is equals to 5, we will have poles on both the sides of a circle. In Butterworth filter, we equate the poles to both the side of a circle. So 5 2s will be 10. So 9k values should be found. Till 9k values we have to find the poles. But whenever we have the negative sign here, it is left hand pole. Whenever we have right side, it is positive. We have to discard it. So the concept is like that. Here what we will do is, we have n value 5. We can directly see a table that is given to us. The table is here. If order is this one, then your normalized filter table will be this one. If we know this table, we can directly substitute the values, or else you will have to do all this process, which will become hectic. So by hurting this table is way more easier than that. So here we have n is equal to 5, right? So we have to write this equation. I'll show you how to write that, okay? So now our Hn of s will be equal to 1 divided by, you don't forget 1 divided by. Whenever you write these things, you have to write it as 1 divided by. But suppose if they give us order is equal to 4, you have to write 1 divided by s square plus 0.7s. Okay, so when I write 1 divided by s plus 1 into s square plus 0.6180s plus 1 and s square 1.6 8s plus 1. So this is the equation given. When you solve this equation, the below equation, you will get a value. This is the value. When you solve the below equation, you will get this value. This is Hn of s. What is meant by Hn of s? Hn of s is the transfer function of normalized low pass filter. Transfer function of normalized low pass filter. But we want analog low pass filter. This is what is asked in question. From normalized, we want analog. It is low pass only. You don't need to change it to high pass, band pass or band stop. You have to change this normalized low pass into analog low pass. So to change normalized low pass, this normalized low pass transfer function into analog transfer function, first we need one more thing, that is cutoff frequency. As I said you, after we found the order, we found the transfer function. After this, we have to find the cutoff frequency. So the formula of cutoff frequency is omega c is equal to omega p by 10 power minus kp by 10 minus 1 whole power 1 by n. So this is the formula of omega c. When you find this omega c, you will get 4.58 radian per second. After this, to convert this normalized low pass filter into analog low pass filter, we have a formula. That formula is, you have to learn this table for that formula. Okay, so to convert normalized low pass into analog low pass, we have s, in place of s we have to put s is equal to s by omega c. So whatever omega c we have got here, that will be used now. So wherever s is there in the transfer function, no, this transfer function, wherever s is there, actually when you solve this, you will get this transfer function, right? Here in the place of s, you have to substitute s by omega c. Omega c value is s by 4.378. So this should be substituted here. After you substitute, take LCM and solve, you will get this final answer. So this Hn of s is converted to Ha of s. This is one type of question.